Hello everyone. Welcome to another learning session of Foundation of Programming at CodeMode, where you learn by practice. Currently you are learning about latest in technology, and in today's class we will learn a new topic called From Dumbness to Intelligence. Before I start, don't forget to like this video and subscribe our channel, especially if you are watching on YouTube. For complete course and related practice, go to our platform my.codemode.us. Let's begin. We learned that computers simply follow our commands, and those commands are nothing but the code we write. Now, is it possible to make a computer intelligent? Artificially intelligent, indeed. Indeed, it is possible. Now, let's take an example which I briefly touched upon in the last class. If I capture a lot of data about what I do, especially in the morning time, what time I wake up, what time I get ready, I check the traffic from the Google Maps before I start my car. I drive to work, I pick up the sandwich and the coffee from the local Starbucks. I fill the gas in my car sometimes and arrive to office to attend morning meetings. If I look at the pattern by observing the data, I have learned that on Mondays, I usually start early. If I don't start by 8 o'clock, I'm going to, see a lot of traffic on the road. And most likely I'm going to miss my meeting or at least be late. So I usually set up my alarm to wake up early on Monday morning. Now imagine I write a computer program to analyze this data, the data I have, captured and stored in the last 1 year or maybe 5 years. The more data I store, better it is, and I'll tell you why. But if I capture all the data and write a Python program or any computer program to analyze and find a pattern, I should be able to see that the days I woke up late and I had a meeting, I may find some correlation, some connection between the time I wake up versus time I arrive in the office, because the traffic pattern had changed during that period. With the program, the program may be able to give me a recommendation and tell me to skip the coffee or skip my breakfast on certain days if I am going to be, if I want to be in the office on time. Now, I give you a very basic example, but the idea is to look into the data, identify a pattern, and plot that on a graph. So if I take this, I'll give another example. If you look at the home prices in a city for every year, and this is the price, and this is year. If you plot a graph, eventually you will see that the prices is kind of increasing. It may be a straight increase in some cases. You can more or less draw a line like this, or you can even find a mathematical equation that exactly represents something very, very close to the graph I plotted. Based on that, the mathematical equation, I can say that for a given year, the value, if this graph represents the value, if the graph represents the data, more or less for this year, the price is going to be somewhere here, because this graph is nothing but the plotting of the pattern. So it's relatively easy to make a prediction. And that is what we talk about when we say what will be the value of the median price of the house in 2030. Computer may be able to give me a smart value. The reason I call it a smart value, because it is based on some mathematical equation. If we can give the data to the computer, and we can give different type of equations in our program and tell computer to find the best possible graph, best possible correlation between the price and the year, computer may be able to tell us the possible predicted value on this graph for a particular year. So we learned three things: giving a lot of data, writing a program to help computer identify the pattern using some mathematical concepts. It could be statistics, it could be probability, some calculus, linear algebra and all that. And finally, making a prediction. I'll give you another example. When we, as a human, when we look at a dog, we know it is a dog because our brain since childhood has learned how how does a dog look like. The eyes, the legs, the skin, the size, all of that part. We know that it's a dog and not a cat. How did we learn? We know that certain characteristics, certain physical attributes have, in terms of the eyes, in terms of the nose, we know these are the legs. One leg may be hiding here, another leg, this is the tail, this is the fur, and all of that. If we can tell a computer, we can give a lot of pictures of a dog and also maybe cat, and tell computer that, in each of these pictures, capture and find, we tell them how eyes look like, how they are distance apart, from the distance from the nose, and lot of data about a dog from different pictures, and also data about the cat. And we tell them that if you find something like this, actually it is a cat, and find something like this, it is actually a dog. Once we train our software program to analyze this massive amount of data about a dog and physical characteristics, then by giving a random picture of an animal, our program may be able to tell us that it is a dog or it is not a dog. And that is what we talk about making decisions. Now, this technique of learning from the data using different computation model, different mathematical model, and giving us a predicted value is we refer as artificial intelligence in computer science. That's all in today's class. If you have any question, post it in the community on my.codemode.us. Also take time to solve the quiz associated with this concept. It will not only make you practice, but also test your knowledge and understanding. I'll see you all in the next class. Keep learning.